All right, everybody. So what we're going to be looking at today is finite state machines again. This is section 13.2 in your book. Um, we already did one lecture on this, but that lecture was taken up essentially with just one big example. And because it was one big example, it was more complicated than some of the simpler stuff. So, what we're going to do is we're just going to look at homework problems in this lecture, basically. And, hopefully these will be simpler and easier to understand. So, just to remind us of what we were looking at, remember that what we had was so our finite state machines, I'm not going to write the whole definition here. This is just a reminder, but our machine M was a group of S, I, O, F, G, and S naught. And so what these were states. That's the possible states, the possible inputs, the possible outputs of your machine. Those are like actions that the machine should take. F is mapping a map of inputs and state and current state to the new state, which could be the same as the old state, but doesn't have to be. You have G, which is much, that's the same. Hold on, I'm going to copy it, duplicate. So G is a map of the inputs and current state to an output, which may be nothing. And then you got S0, which is your starting state. Now let me move all of this down so I can hopefully separate it from the title here. Oops. Okay. Yeah, that worked. Okay. And so that's what we were looking at before. And we talked about state tables and state diagrams, but we only did one example of each. So let's look at the homework now. So this is actually going to be 13.2.1 in the textbook. And what we're supposed to be doing here is we're going to be given a table and we're going to be drawing the diagram. So draw a state diagram for the machine. I'm just going to write FSM, finite state machine, with this state table. So the state table that they give us looks like this. They say state, because they all say state. And then what you've got is your inputs are 0 and 1. That's typical on these. If they just have your inputs numbered like that. And 0 and 1 again. Inputs. I think I didn't leave enough room, so let me move this down. And what goes here is this is the function f, and this is the function g. And what you've got are your possible states are S0, S1, and S2. So you'll see that this is a lot more simple than what we had in the previous section where we were looking at, I think, 7 states, right? This is only 3. And then the rest of the table looks like this: S1, S0, S0, S2, S1, S1. And here we've got 0, 1, 0, 1, 0, 0. And this is our state table. Okay, so just to remind ourselves of what's going on here, the way you would read this is like, so this is not part of the answer, but this is just to make sure we are on the same page here. So suppose the current state is S1 and the input is 1. What is the next state and the output. Okay. Now, again, this is not what we're actually being asked to do here. This is just to make sure we understand what the state table is. So what you would do to answer this question is you've got the current state is S1, right? So right here. And then the current input is 1. So that's here and also here, right? Inputs, inputs. Um, these are outputs, but these are inputs. Okay. And so when you're looking for what's going on here, well, if you're in the row for S1, that's your current state. And then in the column, you're here, but also you're here. Because we have these two functions, f and g, that do different things. And that's why you're dealing with two columns at the same time. And so when we have this, then what we can say is that the new state comes from G. Sorry, comes from F. I don't know why I said G there. And the output comes from G. And so you just read those from the graph as follows, right? So your current state is S1 because I said so. Your current input is 1 because I said so here. So you just go to the intersection of those two and you're here. You see S2. That's the function f. The function f tells you the new state. So S1 and 1 leads you to S2. That's the new state. The other intersection is over here, S1 and 1. And this is going to be the output. So in this case, it's 1. Right, so does that make sense? So that's not the question that was being asked, but that's how you read this state table. Okay, now let's actually answer this question. So the diagram here is what we actually wanted, state diagram. So for the state diagram, if you've got 3 states that you see here, S0, S1, S2, you put those in circles. So S0, S1, S2. You can arrange them however you want. I don't know why I made that one really big. Just did. Still did. There you go. And then what you want to do is you draw arrows for the state transitions, right? So right here, you can see that S0 can go to S1 or S0. So S0 goes to S1 or S0. So S0 could go to S1. That's if you're here, right? In order to go to S1, that would be the input of 0. This is what you've got right there. So S0, input 0 goes to S1. That's what we have. And then you number it on top, 0, because that's the input that would do this. And then you come over here to the input of 0. And this, it would be the output. In this case, the output is 0. So you put that there. Right? So let me just erase the colors here. Right, so what we just drew corresponded to this row and this column, right? So the input 0, that's the first number on the list. The output is 0, that's the second number on the list. And it goes from S0 to S1, that's the arrow. Okay, and then so you just do this a bunch of times. So like the next one is going to be, what if you have an input of 1? Then you would go to S0. So that would be, take off that and go here and here. So what does this row and column do? Well, we've got input state as 0, current state as 0, inputs 1, output is as 0. So old state S0, new state S0, that is a loop. Okay, and then the input that does it is a 1. So the number on top is a 1. And the output is here is also a 1. All right, and so that takes care of this whole row, right? So 2 inputs, so you have 2 arrows. This is the input of 0, and this is the input of 1. First number on the list is the input. Now we got more to do, so let us do that. All right, next row. So now current state is S1, and it can go to S0 or S2. So S1 can go to S0, or it could go S2. Right? So I'm just going to draw both of those arrows now for S0 and S2. Now, what are the inputs that do that? Well, based on the format of this chart here, right? Input 0, input 1. So this is input 0, and this is input 1. So this is input 0, and this is input 1. Then you say, what are the outputs? Well, it's input 0, output 0, input 1, output 1. So 0 and 1 are the outputs. Like that. And then that's that whole row. So the third row, S2 can go to S1 or S1. So just S2 to S1. You can draw two arrows, but the way they normally do it is they draw one arrow like that. And then what they do is they double up on the numbers. So like you end up going S2 to S1 for input 0 with output 0. So 0, 0 for the numbers, 0, 0. But also, if the input is 1, you also go to S1. And if the input is 1, the output is 0. So 1 would be the input, 0 would be the output. So again, input, output, input, output. So the output was 0 both times because there's two zeros here, but it was input 0, input 1 because input 0, input 1, 0, 1. All right, and that's the whole state diagram. So that's what we were coming up with in that problem. So this is the answer here. Come on now, I don't want a square. Come on, I don't want a square. That's so frustrating. Once it decides you are drawing a square, it won't let you draw a rectangle. Super annoying. Okay. All right, so that's what you were doing in that problem. This, of course, remember, This, of course, remember, was just to make sure we understood what was going on here. Now let's look at something else. Let's see if we can draw a state table given a state diagram. That's the other main type of problem. So given the state diagram, draw the state table. And so this is going to be, which one are we going to do? We could do any of these here. Let's go ahead and do 2C. So this is 13.2C. No, 13.2, 2C. Problem 2C. Okay, so what's the table look like? So I've got to draw it. So let me draw a circle. A little bigger. Duplicate it. Come on now. Duplicate it again. Duplicate it again. There we go. What does it look like? So I have to draw it here. So this is S0, this is S1, this is S2, this is S3. Then they've got an arrow like this, that's 1, 1. They've got an arrow like this, labeled 0, 0. They've got a loop, labeled 1, 1. They've got an arrow like this, labeled 0, 0. They've got a loop here labeled 1, 0. They've got a diagonal arrow like this labeled 0, 0. They've got a diagonal like this labeled 1, 1. And they've got an arrow over here labeled 0, 0. And then also they write start like that. Now, by convention, though, you'll notice that in the definition here, way up here, they say S0 is the starting state. So technically, like your states could be called something else, and then you assign one to be S0. But if you're using the names S0, S1, S2, then you must have decided that S0 was the starting state already. So every one of these pictures, the start is actually S0 because S0 is the start in our notation. So they all have this pointing at S0. It's a little bit weird that they do that, but they do it. Okay, so there's our state diagram, and we want the table. So in order to do the table, you have to remember how to do this. So we have S0, S1, S2, S3. You just put your states there. You can label them. You can say state. Then you've got your function f, and your function f is going to have what inputs? Well, the inputs are whatever you see for inputs here. So remember that the first number is inputs. So 0, 1, 1, 0, 1, right? They're all zeros and ones. That's what it comes down to. So you know it's just 0 and 1. That's the inputs. Also, that's the outputs. Then you got your function g. And again, it has the same inputs, 0 and 1. And that's it. That's what we need. So now what we want to do is we want to fill out this table using the information here. And so just basically make sure you know, we just have to figure out what goes in every box. It's not that hard, right? So like this box right here, what goes there? Also what goes here. So if you're trying to figure out this, that would be if you're in state 0 and the input is 1. So you look at all the arrows coming out of S0. There's one here and it has a 1. There's one here and it has a 0 for the first number. So remember, the first number is the input. So this arrow is input 1. This arrow is input 0. So this must be the one that we're talking about, this arrow. So that goes from S0 to S3. So that's what goes there. And then the output is going to be what is the second number. So the second number in this case is also 0. So that goes there. So that's this arrow right there. And these are the numbers that you need. Now, what about this one right here? This is S0 and the input is 1. So that's the other arrow leaving S0. Must be this arrow, right? That one has an input of 1. So this arrow and these numbers go here. So this is S0 to S1. So this is S1. The input is 1 and the output is 1. So this is the output. So you put a 1. Okay, and that's it. We're going to do this several more times. It's not that hard. So like S1, you say, okay, what does S1 do with an input of 0? Here, right? This way. S1 input 0 this way. So that's S1 to S0. That goes there. Also, input 0, output 0. So that goes here. Now, what about input 1? So you're here. S1 input 1 is a loop. So that's S1 to S1. That goes here. Input 1, output 1. So that's going to go here. Like that. Next row. S2. So the 0 is here and the 1 is up here. So 0 and 1. So the 0 input goes S2 to S3. That's S3. The 0 input has input 0, output 0. So the output goes here. Then you've got input 1. Input 1 goes up diagonally. So S2 to S1. That goes here. And then input 1, output 1. So that's there. Last one, S3. So S3 looks like input 0 is going up and input 1 is a loop. So input 0 is S3 to S1. So that's this direction. So 0 and then S3 to S1. So this is S1. Then input 0, output 0. So this is a 0. And then, yeah, that's it. So then what about input 1? Input 1, so that's here. S3, input 1 is a loop. So that's S3 to S3. So this is S3. And here you've got input 1, output 0. So this is a 0. And that's it. So that is the state table representing exactly the same information that's in the state diagram. Okay, so again, not that hard, but you should be able to do both. You're probably going to have one of each on your final exam. Not your final, but your last test. Not too bad. Okay, so yeah, so that's something. Let's see, what else can we do? Oh yeah, so I mean we can talk about this. So let's do 13.2.3 A, just A here. This is a different type of question. So they say find the output generated by input 0, 1, 1, 1, 0 for the machine, for the state machine in exercise 1A. Now, I think we have exercise 1A, don't we? Isn't that what we did here? I think it must be. Wait, where's 1? 1, 0, 0, 2. Yeah, yeah. So this is the one for 1A. So let me just duplicate this here so we have it. Duplicate, bring it down. And there you go. All right, so this isn't that hard. Basically, what you're doing is you've got, you can kind of keep track of this various ways. So we can keep track of the current state. Oops. We can keep track of the current state and the input and figure out what the next state is. And we should be able to trace this. So current state, input, output, and then the next state. All right, so what does this look like? So what they're doing here is they're taking these numbers right here, and those are your inputs. So we can just label those 0, 1, 1, 1, 0 there. We already know those. And we have to basically just figure out the output and the next state for the whole thing, for this input. So the way you start here is, well, we know the input because they told us it. And what are we going to use for our current state? Well, that's why you have a starting state, right? You always start in S0. So we know that we're starting in S0. So everything that is labeled right now is what we're given. And then what we have to do is basically just trace this through several rows. And it's not that hard, you will see. So let's just do it. Right? So it's basically repeatedly doing what we did in the previous problem. No, it's basically what we did here. All right, so let's try it. So if you're in the current state of S0 and the input is 0, what happens? Right? So you know that you are current state S0, current input 0, right? So you here and here. So what is your output and what is your next state? I have these in opposite order from the way we've been doing them, but whatever. So right here, this is going to be your next state, right? S0, 0. This is your next state, S1. So this is S1. And what is your output? Because that's what they actually want. Your output is going to be 0, right? S0, 0 gives you 0. Actually going to put this in a different color or something. 0. Okay. Now what you're going to do is now you're in, oops, now you're in S1. So that comes down here. You're in state 1. So now you're in state 1 and your input is 1. What happens? Right? And again, you just look at the chart. So if you're in state 1, oops, you're in state 1 and your input is 1. That means you are state 1 and your input's 1. So here, like that. So what does that tell you? That tells you two things. It tells you that your next state is going to be S2. I don't like this color. Switching to a darker one. And also, it should also tell you that your output is going to be this number 1. Okay. All right. So then you take this, carry it down here. This is now your current state. Now you're in S2 and the input is 1. So what's that mean? You're in S2 and the input is 1. What's that tell you? Well, it tells you your next state is going to be S1. Having trouble keeping these lined up. S1. And also it tells you that your next output is going to be 0. Not next output, the output is going to be 0. So this is a 0. Okay. So you take that, bring it down here, S1. Now you're in S1 and your input is 1, which actually is a row we've already seen before, but we'll have to do it again. S1, 1. So if you're in S1 and the input is 1, you go to S2. This is S2. S1 and 1 give you a 1 for the output, so that's a 1. Last row. Now we take the S2, carry it down here. S2 and 0, so that is S2 and 0. So S2 and 0, your next state is going to be S1, although we won't care. And if your input is 0, your output is 0. So there you go. So what do we get? So first of all, we trace this out, and what we see for the output is that the output is right here, 0, 1, 0, 1, 0. That's the output. 0, 1, 0, 1, 0. Based on just what we just figured out. Okay, so that's something you can do. And again, it's basically just if you can solve this problem where you're given a current state and an input, what is the next state and the output? And you just repeat that for as many times as you need when they give you a problem like this. The input just changes. 1, 2, 3, 4, 5 inputs. 1, 2, 3, 4, 5 outputs. We're left in state 1, but they didn't ask that. They just asked for what is the output, which we calculated in this column. 0, 1, 0, 1, 0. And so that's it. So that's how you do these problems. And probably we'll code up a finite state machine just so we can see what the code might look like in a future lecture. But I think that's it for now. So hopefully, hopefully that made sense.